I give you two more examples of non-holonomic systems. Okay? So mathematically speaking, non-holonomic systems pop up when there are constraints on velocities and not on positions. So when you have constraints on geometry, like for example, something must stay on the plane, or something must rotate about a certain point, or something, these are all geometric constraints. But you may have a constraint on velocity, like velocity must meet certain criteria. Then systems with constraints on velocity or on higher derivatives will be non-holonomic. Another very interesting example of non-holonomic systems are space stations and the like. You see, on the space station orbiting the Earth, of course, as any other system, it must satisfy conservation of momentum, which means if it begins moving one of its robot arms to one direction, it must move in another direction because of the conservation of momentum. Okay? This actually mathematically appears as some condition on velocities, right? Because in momentum you have velocity, right? So mathematically it pops up as constraint on velocities. You can't have arbitrary velocities because if you move something, then something must move, right? So these systems are non-holonomic. Many people have done PhDs and other things on dynamics of space structures because exactly they are good for research because they are very difficult because they are non-holonomic.